Find the maximum outflow in cubic feet per second. In this problem, a river reach experiences inflow due to a flood, and the inflow hydrograph is provided. The wedge storage factor, reach travel time, and base flow are also provided. Since the inflow hydrograph is in 1 hour time steps, delta T equals 1 hour. In this problem, we'll use the Muskingum River routing method to determine an outflow hydrograph from the river reach, where the outflow in a time period is the function of the inflow from that time period, the inflow from the previous time period, and the outflow from the previous time period. These three factors are weighted by coefficients C1, C2, and C3, which depend on the reach travel time, time step, and wedge storage factor, where the sum of coefficients C1, C2, and C3 equal 1. Plugging in our known variables, coefficients C1, C2, and C3 equal 0.3220, 0.5254, and 0.1526, respectively. A quick check is made to ensure that the coefficients sum to 1, and they do. Now the routing equation can be updated with the known coefficients. At this point, we're ready to begin developing the outflow hydrograph. Keep in mind that the time is in hours, and the flow rate is in cubic feet per second. The outflow for the first time period from hour 0 to hour 1 equals 0.3320 times 23 cubic feet per second plus 0.5254 times the inflow from the previous time period plus 0.1526 times the outflow from the previous time period. Since we know the base flow equals 23 cubic feet per second, we'll assume a steady state flow regime of 23 feet per second occurred at the previous time step. Therefore, the outflow from hour 0 to hour 1 equals 23 cubic feet per second. To find the outflow during the second hour, the inflow, previous inflow, and previous outflow are plugged into the routing equation, and the second outflow, rounded to the nearest integer, equals 33 cubic feet per second. This calculation is continued for all time periods, and the outflow hydrograph is completed. The problem statement asks to find the maximum outflow, which is most clearly 80 cubic feet per second. When reviewing the possible solutions, the answer is D.